Now, which is smart transportation, and the first finalist is Geospoc, and Richard Baker, who's the Chief Executive Officer, is going to come and talk to us about their proposed solution. Richard.
Thank you. Good morning, everybody. I hope you're well. Firstly, thank you, Liverpool, for hosting this International Business Festival, and specifically for the Smart City, Smart Nation workstream. It's really exciting to be here. As introduced, I'm Richard Baker. I'm the CEO for Geospoc. We're a UK software company. We're based in Cambridge. I'm going to just explain a little bit about the company, our origin, and what we do. And then specifically the Merrill challenge that we're looking to address is all about current and future transportation mobility strategies, and mobility being a very significant component of any smart city. As I talk, I will have a video of our platform running in the background, which really is a little journey through time, really, of a number of cities and projects that we've worked with around the world, and it tries to depict really the importance that we see in metadata, and particularly the metadata that we're going to talk about is geospatial, GIS, and location. We are a space and time software engineering company. We concern ourselves with extreme data sets, but particularly those that relate to location intelligence. We're based in Cambridge. The image that's on the screen is a snapshot of Cambridge Smart City. As I run the video in a few minutes, the product that's on screen is our Illuminate front-end visual analytics engine. And so I have to do the technology for a second just to set the scene. The business was founded by a young gentleman called Dr. Steve Marsh. Steve is from Manchester, and we won't get into the Manchester-Liverpool discussion today. But Steve did his undergraduate at Manchester and did his PhD at Cambridge University. He's a computer scientist. And during his PhD, he took on the challenge of looking at a very significant computer science neural problem. He set about to solve how would you emulate 1 second of human brain function in a supercomputer and in software. And he went head-to-head with IBM, the Blue Gene machine, back in 2015. And IBM indeed did take on an emulation of human brain function. And human brain function, for those that aren't neural scientists in the room, and I'm certainly not, is 1 trillion synapses and 100 million neurons all recomputing every 1 second. It's the real definition of a complex quantum compute environment. Steve set out and built a supercomputer architecture and a software platform, and indeed what took IBM 2 weeks to solve, Steve did get to in 1 second, and that was the foundation of Geospoc. The business is now 5 years old. We're a team of 40 PhD computer scientists, and we're operating internationally, and particularly in smart cities. The challenge that we took on in Cambridge was looking at the practical realizations of what makes a smart city, and we're big believers that this has to be a data-first answer. We sit on top of infrastructure. We run a cloud platform, but we're very interested in being that logical translation layer between all of the underlying physical infrastructure and how emerging services and applications are going to use that infrastructure to build smart cities and indeed to build citizen services. The image here is a snapshot on Cambridge, and we've got a blend of streetlight data, we've got police incident reports, we've got all of the out-of-town park and ride locations, and as I go through the explanation today, we start to blend feedback from all of the underlying sensors in the city, but also take into account GPS signals, people movement, and we really look at the whole dynamic picture of what happens in a city day to day, and how do you start to use data to build insights on serving the city and serving the citizens and solving problems like mobility and transportation. This is our Illuminate platform, and it's going to tell a few stories. We start in New York, looking at New York taxi city data, 1.3 billion records, and our particular forte is operating very differently in the database market from traditional relational databases. And I won't go on about the technology. I want to get to talking about cities, citizens, and challenges we face as society. But ultimately, we recognized a few years ago that the planet is producing exponential amounts of data. 90% of the data that exists on the planet today has only been produced in the last 3 years. And for the last 40 years, the world has grown up on various forms of relational databases that have ultimately housed human-generated data, text files, Excel, Word, our emails. Those relational databases tend to fall over at 10 billion rows of data. And ultimately, query time goes up when you're trying to read, write in and out of a database. So really, most of those databases today are not fit for purpose to be the operating systems behind a machine-to-machine environment or an intense, complex environment like a smart city. So the core of Geospoc's business is a re-architected database that deals with petabyte-scale data storage and quick retrieval. It's real-time simulation of environments, and it's real-time visualization of environments. And what we get excited about when we think about real-time scenarios is how will 1 million autonomous driving cars function in a city of the future? It is the essence of a hive mind challenge. Each car will in itself be communicating in its own proximity. It has its sensors, it has its Wi-Fi, its Bluetooth communication. It's got machine-to-machine communication to the car in front and the car behind. And as we see from many of the stories in the papers around the world, building fleet management systems that allow autonomous cars to function in our cities is a big challenge. And today the challenge is being addressed by many manufacturers excuse me, by looking at the in-car solution. We're spending our time thinking about the contextual environment of the city and how you bring that contextual understanding to the fleets of new logistic systems that want to understand how to operate efficiently and safely. I think when we think this through, the car that's navigating or the truck that's delivering goods to our shops, to our homes, really needs to get continuous feedback from the city. And Geospoc is building the operating system for the physical world. That's our mantra. And I think for Liverpool, when we think about multimodal transport, how do we solve congestion? How do we start to think about what builds congestion over time in a city? And that tends to be multiple uncorrelated patterns of behavior that up until today really can't be analyzed together at the same time. It's interesting as I arrived today that we have a little storm hitting the city, and of course weather patterns impact congestion, they impact timetables, they change the movement of people, they nudge us from perhaps being on our bicycles to getting in a car, adding to the problem of building up congestion in key parts of the day. Ultimately, the platform we've built is all about bringing all of those underlying uncorrelated data sets together and looking for the hidden patterns that help you start to build an informed view of how to address logistics. How do we plan budgets? How do we become optimal in the way that we ask our citizens to move around our cities? I think the concept of nudge behavior in the next few years is going to become important for smart cities. How can I be encouraged to maybe stay at home for 10 or 15 minutes more in the early morning and not join the congestion on my trunk road and build up that problem at the sequence of traffic lights? Actually, the data is already there. We can pick up GPS data, we can pick up the IoT sensor data in the car. Most cars are carrying an IoT SIM today, and we've got IoT and Bluetooth sensors up and down our high streets. We can really dynamically start to plan city as a platform and start to build citizen services that help us really look at optimizing our assets and encouraging a different set of behavior. We recently presented to the Metropolitan Police in London as part of their Innovation Day, and the real benefits for society out of really understanding deep contextual understandings of cities can be seen in how do you optimize police patrol. If I was to put 2 patrols or 3 patrols in a particular area, how does it help my crime ratings? We went through a particular scenario where we've analysed all of the police incident reports in the UK and started to drill down into each city to look at the different factors behind crime. It was interesting to see that anecdotally, bicycle crime in London only represents 1% of overall crime, whereas actually in Cambridge, we're a big community of cyclists, it represents 11% of crime in the city. But when we analyse that even further, ironically, most of the crime for bicycle theft happens outside the police station in Parker's Piece in the city centre of Cambridge. We're moving towards a city platform that can start to digest legacy data, but ultimately start to build in new real-time data that starts to steer toward predictive modelling. Some of the illustrations that are happening here is about starting to look at start and stops of journey. Where do citizens come from and where do they go to? What are their dwell times in between? I think it's pretty important to understand that today, for many cities, I might leave the south of a city, but I'm heading really to work at the north of the city. But because I can't get round the access roads, or maybe there isn't a bypass, I'm going through the city, causing congestion, but really my exit point is at the other side. Really understanding the patterns and movement of people help us start to form an opinion on how predictive science can help us shape real-time the cities of the future. In that illustration I gave about autonomous vehicles, self-driving cars, we have to understand that whilst the car and the fleet management system can look after itself, it needs that symbiotic relationship with the city, because the city needs to be able to tell it, or that fleet, that there is an emergency vehicle getting priority coming against it. So perhaps it's not a good time to be thinking about overtaking if traffic is slow. Cars by themselves can't get that intelligence. They're going to rely on an operating system, and we're firm believers that cities as platforms are a big part of how that intelligence system is going to work overall. We heard a little from Paul earlier about open access Wi-Fi, federated views. We see from asset managers and building owners some really innovative thinking about, we've got Wi-Fi data and Bluetooth data from footfall in our shopping centres. If I take the very sad case recently of House of Fraser having to shut 31 shops in the UK, if you drill into that and look behind, it's an asset manager in Hong Kong that owns House of Fraser. And their headline statement was, the centre of gravity for the cities that those shops are in has changed. Urban development has pushed out, and where those House of Fraser stores are, the footfall and the demographic has changed. And so those shops are no longer in a good position, and they're not attracting the right type of customers. Why does that need to be a 10 or 15 year assessment problem? That can be a real-time problem where we're looking at footfall, we're looking at the attractiveness of our shopping centres and the types of quality of shops that we put in certain locations. So for Liverpool, when we start to think about mobility and transportation problems of today, our offering to Liverpool is all around building a Liverpool City as a platform, data platform. It's about bringing all of the legacy data together with all of the new systems and architectures that are going in to build a discovery platform. Time has gone where you sit and write queries and ask for a predetermined outcome. You need to allow the data to inform you on the fly what is the best thing to do. How do you make real-time recommendations? And ultimately, in a world where digital twins start to rise, and ultimately I think urban planners will have an opportunity to scenario build and model their cities before they commit to infrastructure or before they commit to budgets. Getting on top of your data and understanding that contextual environment is going to be critical. So for us, we believe we have a platform that can operate at scale across different data sets, but ultimately already have been implementing for other cities a real bringing together of those physical assets and how they meet the world of new services and new applications for citizens. So I want to thank you for your time this morning, and I look forward to any questions you may have. I think I've got about a minute left.
Very good. Any questions? Richard? Okay, well, really interesting.
Thank you very much.